Hello friends, welcome back to Scientific Blunders, where you learn the don'ts first. So today we're going to continue our series on laws of motion, and here's the problem. In the arrangement shown in the figure, the ends P and Q of an unstretchable string move downwards with uniform speed u. So these are the ends P and Q, and they move downwards with a uniform speed u. Okay, pulleys A and B are fixed. As you can see, they're attached to the ceiling. Mass m moves upwards with a speed. So this is mass m, and we're given four options: 2u cos theta, u by cos theta, 2u by cos theta, and u cos theta. And if this problem seems familiar to you, then you're probably right in thinking that it's not a new problem. It's in fact a very old problem from 1982. So let's get started. Let me just scroll down a little bit to create some space. And the first thing we want to do is check units, right? Because we don't want to solve a problem if there's just one option with the right units. So u has speed, or u has units, meters per second, units of speed. Cos theta has no units. So that means all four of these options have the right units. So unfortunately, we do have to solve this problem. And that's why I'm even making this video. So I've actually copied two instances of this figure because I actually want to keep this for future use. So let me scroll down to the part where we're actually going to solve it. And so we know that these two ends move down with speed u. Okay, someone's pulling on them. So intuitively this mass is going to move up, correct? And we need to figure out the speed at which it moves up. So let's say it's moving up with speed v. And so one approach is to realize that this string is inextensible, correct? So that means every point on the string is going to have the same speed. We cannot say it has the same velocity. So just to give you an example, let's consider a pulley, okay, a fixed pulley, okay, and then there's string running on both sides of the pulley. And if this end moves down with speed u, this end is going to move up with speed u. So the speeds are not, or the velocities are not the same, but the speeds are the same. And this is true even if the even if the configuration is a little different. Let's say there's a pulley like this. This is how the string runs over the pulley. If this end moves down with speed u, what can you say about this end? So this is going to move to the left with speed u. So because the string is inextensible, the speeds of all points in the string are going to be the same, but not necessarily the velocities. So depending on the configuration, correct? So in this case, by the same logic, if this end is going to move down with the speed u, this end is going to move in this direction with the speed u. And similarly, this end is going to move by symmetry, is going to move in this direction with the speed u. And so v is just going to be the resultant of these two vectors, correct? And what is the resultant of these two vectors? So u at an angle of theta to the vertical in this direction, and a similar vector u in this direction with the same angle theta with the vertical. So the component of this vector in the vertical is u cos theta. This vector is also u cos theta. So the resultant is 2u cos theta in the upward direction. And clearly u sin theta in this direction is going to cancel with u sin theta in this direction. Okay? And yeah, it looks like we are done, right? It was quite quick actually. So 2u cos theta in the upward direction is the velocity of this point. So just the speed would be 2u cos theta. So this is definitely seems very reasonable to solve this problem this way. But I did get one other idea. So again, let's just another way to do it, just to confirm that this answer is correct. This end is going to move down with speed u. So this is going to move up with speed v, and we need to calculate that in terms of u and theta. Okay. I have a feeling, this is definitely seems reasonable, but I also feel that, if this end is moving up with speed v, if you look at this point is only going to move in the upward direction, correct? So I have a feeling that the component of this vector along the string should also be u. So what do I mean by that? So let me write down the equation first. V resolved along this direction. So the component of v in this along the string is what? It's v cos theta. And because the string is inextensible, the component of any velocity vector of a point on the string resolved along the string should be the same, right? Should have the same magnitude. So if this end moves down with speed v, intuitively I also feel that this vector resolved in the direction of the string should have the same magnitude as this. So v cos theta is u. I feel this is also correct. So v in this case would become u by cos theta. Okay. These problems are great because they require a lot of thinking, but the answers are just one line. I just love these kinds of problems. Okay. So v equals u by cos theta, and this is also in the upward direction, correct? By symmetry, this block is only going to move vertically up. Wait a minute. So we got 2u cos theta in the previous case and u by cos theta in this case. Which one of these is correct? I really encourage you to pause the video here and think about this, and assuming you're done pausing and are done thinking about this, let's just, obviously both of these are dimensionally correct, so we cannot look at units and figure out which one of these is correct. But let's just consider the case when, theta is 60 degrees. So theta, roughly it's something like this. This looks like it's roughly 60 degrees. So imagine, a real life scenario where theta equals 60 degrees and this is the configuration of the system. So what is v? V equals u by cos 60, and that's 2u. And let's try the same thing here. Theta equals 60 degrees, which means cos theta is half. So v will equal u. So which one of these is correct? Which one of these do you think intuitively makes more sense? See, there are two people pulling on both sides with a speed u. Two people are pulling the same block. Don't you think the speed is going to be higher than the individual speeds of this part of the string and this part of the string? Because there are two strings that are pulling this block. Don't you think? Yeah, I think that intuitively makes sense. So v equals 2u seems to be a more reasonable answer than v equals u for theta equals 60 degrees. Okay, so obviously this is not enough to conclude that this is the right answer, but cos theta is always less than 1, correct? Theta is going to be, let's say, between 0 and 90, so cos theta is always going to be 0 and 1. So v will always be greater than u in this case, correct? But in this case, you could have the cases where v is less than u, correct? If cos theta is less than half. So in general, I feel like intuitively this makes more sense because there are two people pulling on the string. Okay, so you expect this to have a higher speed than the speeds of this point on the string and this point on the string. So intuitively this makes more sense, but we don't have enough proof yet that this is the right answer. Another thing that I realized, and let me scroll down a little bit. This is why I wanted to have that figure untouched so that I could copy it down here. So let's think about this problem a little more deeply. Okay, this point is going to move down with speed u. Okay, this point is going to move up with speed v. So let's say we don't know which answer is correct yet. So v could be u by cos theta or v could be 2u cos theta. But one thing we can say for sure intuitively is that this point is going to move upwards, correct? With some speed v. But the key thing to realize here is that this point is right on the interface between the string and the block. So you could say it still lies on the string. This point lies on the string, and yet it's not moving it's not moving along the string. So that's the biggest blunder we made actually in the first case, right? Because we just assumed that this point is going to move down with the speed u. So because the string is inextensible, the string is going to move in this direction with the speed u. Now that is actually incorrect, because clearly, here is a point that lies on the string, and yet it's going to move up with a speed v, not along the string, correct? Another example, so ultimately if you think about this, we are pulling this down, so this is going to get pulled down, so this is going to get pulled up. So ultimately, after some time this is going to reach maybe this position, and then slowly here, and then here, and ultimately it's going to become flat. Okay, this block is going to move up all the way here. So if I were to track just this point, let's say my focus is only this point, what is its motion going to be? It's going to be straight up, correct, till it reaches here. If I track the motion of a different point, let's say, which point do I want to track? Let's say I wanted to track the motion of some point here. Okay, so if I wanted to track the movement of this point, after some time it's going to be somewhere here. Actually, I should use a different color so that we can see which point we are tracking. So let's say I want to track the movement of this point. Okay, so after some time it's going to move somewhere here, and then maybe here, and then ultimately it's going to move here. So if I were to trace this point, it looks like it's not easy to track this, because it's not moving along a straight line, correct? This, my friends, is the biggest thing to realize, that all points in the string are actually not moving along the string. All points of the string on this side of the pulley were all moving along the string, right? This point is moved down with a speed u, this point moves down with a speed u along the string, this point moves down with a speed u along the string. But on this side of the string, because of this arrangement, because there's another string pulling on this side, every point on the string is not moving along the string, but it's moving in some other direction, correct? This point is moving up, this point is going to have a simple linear motion straight up. This point will have a more complicated, other points, actually all other points on the string will have a more complicated motion, and I am not able to confidently say whether this is going to be parabolic or elliptical or hyperbolic. It could be some other complicated curve. Okay, but the key thing to realize is that all points in the string are not moving along the string. What we can confidently say is that because the string is inextensible, the component of all of these velocity vectors, let's say at this point this has a velocity vector, let me go back to, actually this was a nice color, this point has a velocity vector in this direction, doesn't have to be vertically up, could be some other direction, b dash. This point has a velocity vector some other direction. Okay, what we can say is that the components of all of these vectors resolved along the string are going to be u, because what is the component of this velocity vector resolved along the string? Well, it's already along the string, so it's just u. Now, what is the component of this vector along this string? Well, it's v cos theta, and that still has to match u. Because the string is inextensible, all of these velocity vectors of different points along the string have to equal u. Okay, and so these points are more complicated to track, because like I said, it looks like it's a curve to me, and it's probably another JEE problem for the future where we find the equation of this curve. But all of these other points are more difficult to track, but this point can be very easily tracked, because by symmetry two people are pulling it from both sides, so this point is only going to move vertically up, correct? And so we know the direction of this vector, so, and let's say it has some magnitude v which we want to calculate. So we say that the component of this vector along the string, which is v cos theta, has to equal u, which means v equals u by cos theta, and this is the right answer. So if we scroll all the way up, this, my friends, was the right answer. And so the key thing to realize in this video, there's one big takeaway that I had to summarize. I would say that the component of the velocity of any point on the string along the string has the same magnitude. And with that, I hope you found this video useful, and I'll see you in the next video. Bye.